Alright guys, so today we are going to talk about special right triangles. So they are just right triangles that have some really cool kind of products that come from them. So the first one that we're going to talk about is a 45, 45, 90 triangle. The way that they're named is just based on the angles. So you can see, like in this triangle, we have 45 degrees, and then 90 degrees. So they're not really that uniquely named. They're not really that cool, but they do have some really cool things. So the really cool thing about them is that the hypotenuse of a 45, 45, 90 triangle is the length of the leg multiplied by radical 2. So it will always equal that. So you might want to make like a little formula box up here. So for a 45, 45, 90 triangle, the hypotenuse is equal to the L, I'm going to write L for leg, times radical 2. Okay? So the hypotenuse is equal to the leg times radical 2. And the special thing about 45, 45, 90s are that the legs are the same length. So notice here that the legs are both x in this case, and then the hypotenuse is that x and then times radical 2. Okay? All right, so that is the 45, 45, 90 triangle. There are only two special right triangles, and the other one is a 30, 60, 90. So once again, it's just named based on the triangle angle measure. So again, nothing really that cool. All right, and this one actually has two formulas because the legs are not the same length. So the legs are not the same length, therefore we need two different formulas. Okay, so for this triangle, I'm going to write it in a different color. So for the 30, 60, 90, the hypotenuse is equal to, I'm going to write S for shorter leg, so the short leg times 2. Okay, so the hypotenuse is the short leg times 2. Okay, now the longer leg, so I'm going to write L for longer leg, thank you, is equal to the shorter leg times radical 3. Okay, so the longer leg is the shorter leg times radical 3. So looking at this triangle down here, you can see, you can see that this is the shortest leg. Okay, so the hypotenuse is 2 times that shortest leg, and the longer leg is radical 3 times that shortest leg. Okay. Right. All right, so let's try an example. So down here, number 1, what type of triangle do we have here? Good, we have a 45, 45, 90. It gives it away because we have a 45 down here. So that makes this one 45 as well. Okay, so we're trying to find the value of x, but what is x? Good, the hypotenuse. So we know that the hypotenuse, looking back up at our formula, for a 45, 45, 90 is what? It is the leg times radical 2. So I know that my hypotenuse is the leg times radical 2. So in this case, my hypotenuse is equal to 10 times radical 2. So it'd just be 10 radical 2. Okay? All right, let's try number 2 together. Okay, so what side is missing? Good, the hypotenuse again is the one that's missing. Okay. So how can I identify what type of triangle this is? What gives it away? Yep. Good, the sides are equal, so that tells me once again it's a 45, 45, 90 triangle. Okay. So I know that my hypotenuse is equal to my side length times radical 2. Right? So in this case, my hypotenuse would be equal to my side length, which is radical 2 over 2, right, given to me up here, times radical 2. You with me? Yes? Okay. All right, so to simplify, I need to multiply across, right? What is radical 2 times radical 2? What is it? Good, it's just 2. So you'd get 2 over, multiply down here, 2. So that would just equal 1. So my x, or my hypotenuse here, would just be 1. Okay? Go ahead and try 3 and 4 on your own. All right, you ready to go over these? All right, so for number 3, what is my unknown? What am I trying to find? Good, I need my legs, right? So the only kind of formula I know for a 45, 45, 90 is that my hypotenuse is equal to my leg times radical 2, right? However, what value am I actually given here? The what? Good, the hypotenuse, which is just 8 radical 2, right? So I can plug in 8 radical 2 for my hypotenuse, and that's going to be equal to my leg times radical 2. So I'm trying to find that leg. So what would I do on the right side of my equation to try and get that leg length? What would I do? What if I had 3L is equal to 8? How would I get L by itself? Good, divide by 3. So kind of the same thing over here. I'm going to divide by that radical 2. So just because it's a radical and just because it's an L doesn't mean that I can't still use those same rules. Okay? So if I divide by radical 2 on both sides, notice that they cancel out here, right? If you divide anything by itself, they would cancel. So my leg length would just be 8. Okay. Where are we feeling comfortability level with this kind of, with this equation stuff? 3, 2, 1. Okay. All right. Let's look at number 4. I'm going to warn you, number 4 is like the trickiest. Okay. All right. So we know that the hypotenuse is equal to the leg times radical 2. Okay. What length am I given here? Good, I'm given the hypotenuse, which is 12. So I'm going to plug 12 in for my hypotenuse. So similarly to the last problem, I have to divide by that radical 2, right, to get L by itself. Okay. So my leg is equal to 12 over radical 2. However, do you remember us saying I think it was maybe last cycle, that we do not like radicals in the denominators of our fractions, right? So the way to get that out is something called rationalizing the denominator. You don't necessarily have to know that term, but you need to know that you can't leave them in your final answer. Okay? So what is a way that I can get rid of a radical? Yep. Ooh, you're really close.
Or radical.
Yeah, not the negative, right? So you'd multiply by itself, right? Because you want to undo that square root, so squaring it would kind of undo that, and that would be multiplying it by itself. So he's right, you want to multiply it by itself. However, remember we're working with a fraction, and the only way to keep fractions equal is to do the same thing to the top as what you do to the bottom. So if I multiply the bottom by radical 2, I must also multiply the top by radical 2. So I'm basically multiplying by 1. Okay? So if I do that, notice I can't really mush 12 and radical 2 together because one of them is a whole number and one of them is a radical. So to write that, I just leave it as 12 radical 2. Right? Okay, so then on the bottom, what would radical 2 times radical 2 be equal to? Good, 2. Okay, so notice here, I have 12, that's a whole number, and I have 2, that's a whole number. So my kind of whole number rules still apply. So I'm allowed to make this 6 radical 2. And that would be my side length. Okay. How are we feeling on rationalizing the denominator? That's kind of a hard kind of a hard. Yeah, do you have a question?
Yeah.
Okay.
I did it a different way.
Uh-huh.
I think I still got the same answer.
Okay. Yeah, how'd you do it?
So 12 is the hypotenuse.
Uh-huh.
It's x squared plus x squared equals 144.
Mm-hmm.
And then since the two sides are equal, x squared would be 72. So each x would be 8.4.
Okay.
Does that also work?
The only problem with that is that it would not be considered in simplest radical form. So that's kind of the only problem with that. There's no wrong way in that how you solved that. That's completely fine. But if the question ever asks for you in simplest radical form, that's where you would run into that problem. Yep. Clever though, I like it. All right. All right, so we're done with 45, 45, 90 triangles. Okay. All right, let's move on down here to 30, 60, 90s. Okay. All right, so this time we have two unknowns. All right, let's first identify, is this side right here that it gives us, is this the shorter side or the longer side? Good, it's the shorter side. So you know our short side is equal to 15. Okay. So using our formulas for 30, 60, 90, we know that the hypotenuse is equal to the short side times 2. Okay, so our hypotenuse is equal to that 15 times 2, which is just 30. So our y up here, our hypotenuse is equal to 30. Sounds pretty simple. Okay, so now to find our long side, we know that our long side is equal to our short side times radical 3. So our long side would just be our short side, which is still 15, times radical 3. So you would just write that as 15 radical 3. So our long side, or in this case our x, is equal to 15 radical 3. Okay? All right, go ahead and try 6 and 7. 6 and 7. All right, guys, number 6. All right, so what does it give us? What length does it give us? The hypotenuse, right? Okay, so we don't have to find the hypotenuse, so we're going to need to find the short side and the long side. We know that the long side is equal to the short side times radical 3, right? But that doesn't really help us right now because we have two unknowns. Okay, so we can't just really make up numbers. So the other formula we do know is we know that the hypotenuse is equal to the short side times radical 3. So we can plug in for this hypotenuse that 22. Come on. All right, so we can plug in that 22. So to find the short side, all I'd have to do is what? What would I have to do to get the short side? Good, divide by that radical 3.
Short side would just be divided by 2. Yeah, one of the sides would just have 22.
Do what?
One of the sides would just have 22. Yeah. The short side would just have 22. Because if you find the hypotenuse, you just have to find the short side by 2.
Right.
To find the short side, you just divide that by 2.
Yeah, that's true. Yep. You can do that. You can definitely do that. So either way is fine. So I know that my hypotenuse is equal to the short side times radical 3. Are you with me there? I'm sorry, I looked at the wrong one. I was looking at 45, 45, 90 triangle. All right, so my bad. All right, so long side is equal to, did I get the long side formula right? Yes. Okay, so the hypotenuse is equal to the short side times 2. Okay, sorry. So 22 would be equal to the short side times 2, and that's what you guys were saying, just divide by 2. Oops. So the S would be equal to 11, right? Sorry, I looked at the wrong formula. Okay, so S is equal to 11. So now up here, that's going to help me with my long side, right? So I can just plug this 11 into where I had my S. So my long side, or my x, would be equal to 11 radical 3. Okay. Do you guys want to see 7, or would it be helpful for you just to get more practice? 7? Okay. All right. So I'm going to copy down my formulas now. So I get hypotenuse is equal to the short side times 2. And my long side is equal to the short side times radical 3. Okay, so notice this time I'm given the long side, right? That 9. Okay, so I'm given 9 as my long side. So I know 9 is equal to the short side times radical 3. So in order to get my short side, I'm going to have to divide by radical 3. So my short side is going to be equal to 9 divided by radical 3. Once again, we're going to have to get that radical out of the denominator. Okay, so what do? We have to multiply by what? Good, radical 3 over radical 3. Okay, so that would give us 9 radical 3 over 3. You with me? Okay, so now we can simplify those whole numbers out front, right? 9 over 3 would just be 3, and I keep my radical 3. So my short side, or my x in this case, would be equal to 3 radical 3. Okay, so now I need to think about my hypotenuse. All right, so I know that my hypotenuse is equal to my short side times 2, and I just found my short side as 3 radical 3. So all I do is need to multiply that by 2. Okay, remember I can only multiply those whole numbers together, so that would give me 6 radical 3 for my hypotenuse. Okay, any questions? All right, so I think the best way to really understand the special triangles is just to practice a lot. So today we have an around the room activity. Okay, so the answer key is up on the far right side of the board. So you can start at any one of the stations and you will make a complete circle around. Okay, if you finish that early, feel free to start working on your prep. Okay. So, oh, I lied. I took down the prep. Okay, sorry. That's because the last class had I-step, so I just took it down. All right, so just go ahead and work on that. That should take you the whole class to work on the around the room. Okay?